Greetings and welcome to today's session. In this session, I'll be taking you through the organic chemistry, which is one of the branches of chemistry. We know very well that chemistry is divided into three branches. That is the physical chemistry, we have the organic chemistry, and we also have the inorganic chemistry. So in this session, we shall be going through the organic chemistry, and it is our very first session that we are having as far as organic chemistry is concerned. I'll be taking you through the nomenclature. The nomenclature, where we'll be looking at the naming of different organic compounds. Why do we need the naming? The naming is always done, or it was even done before, for easy identification. We have a number of organic compounds, and therefore a system called IUPAC system was used to do the naming of different organic compounds. IUPAC is what you call the International Union of Pure and Applied Chemistry. So we shall be using the same system as we name different organic compounds. So in this session, teacher Nyirimbibi Isaac is the one who will be taking us through. Let's go direct to the few guidelines that we follow when we are naming different organic compounds. Before we look at these guidelines, I want us to list different organic compounds that we know. Number one, we have those organic compounds that we call hydrocarbons. And under hydrocarbons, we have the alkanes, we have the alkenes. When you talk about hydrocarbons, those are substances which have only hydrogen and carbon only. They have only carbon and hydrogen atoms. So you have alkanes, alkenes, and also we have the alkynes. Then those are the hydrocarbons. Then we have what you call the alkanes. Alkanes, or we can also call them alcohols. Then we have the carboxylic acid. We have carboxylic acid. We have aldehydes. Okay. We have the ketones. We have esters. We have aromatic compounds. In aromatic compounds, that's where we find the benzene and also the derivatives of benzene. Of course, we can add etc. and more others. We have a number of organic compounds, but for today, we are going to look at some of these organic compounds, and we are looking at step-by-step guideline. Which guidelines do we follow when we are naming these organic compounds? So number one, we say we identify the longest carbon chain. And this longest carbon chain is what you call the parent chain. Then after that, we also look at, we identify the functional group. All these organic compounds that we have mentioned here, they have different functional groups. They have given us some sample, like double bond. Double bond is a functional group for alkenes. Triple bond is a functional group for alkynes, and etc. We shall be looking at other functional groups. What is the functional group of alkanes? What's the functional group of carboxylic acids? What about the ketones? We shall be looking at all these, the functional groups. So when we are naming, the first thing we need to look at is the longest carbon chain. From there, we identify the functional group. And then we number. The number 3 is number the chain to give the lowest locants to the functional group. So the functional group should be given the lowest position. So if we are numbering our carbon chain, we have to make sure that our functional group is given the lowest number. Then we also have number 4. We name and number substituencies. The substituencies, we also call them the branches. We can call them substituencies, or we can also call them the what? The branches. And these branches, they can be the alkyl group, or they can be the halogens. The halogens or the halides. The halogens, these are elements we find in group 7 of our periodic table. And that's where we have the chlorine, the fluorine, the bromine, and also the iodine. So that's where we find the halogens. So those ones, they can be some of the substituencies that we have. So we're saying that after all the 3 steps, then we look at the naming of and numbering of the substituencies. Then finally, after doing all that, the last step is assembling. Assemble the name, and this name we assemble it by getting the prefix, what comes first, followed by the parent name, and then we end with the suffix. Suffix, that is the one that comes at the end. So those are the 5 core guidelines that we're going to be following as we name different organic compounds. But before we look at the first example, let's first look at the different functional groups, the functional group of different organic compounds, and also look at different alkali groups, and then finally we can deal with different examples as we name them. For those who have not yet subscribed to our channel, let's not forget to click on the subscription button, but also not forget to click on the notification button, so that whenever we upload any latest tutorial, you're able to get it as the first person. So make sure you subscribe, and don't forget to share with your friends, so that your friends also can always benefit from whatever we discuss. Let's look at this table. This table is showing the common functional groups. So these are common functional groups, though we have more other functional groups. So in this, we have red is representing the functional group. Whenever you see red, that is the functional group. And then this other column is representing the compound class. So we have an alkene. An alkene, that is a hydrocarbon that we have been talking about. It has a functional group of carbon to carbon double bond. I believe you can see that. Then alkyne has a functional group of triple bond. We say that functional group is a group of atoms that are responsible for characteristic or for the behavior of a given substance. So the way a given substance behaves, the way it reacts, that is dependent on its functional group. And these are the functional groups we are looking at. We have seen even the guidelines in naming, functional group is given a priority. We need to identify the functional group that we are dealing with in that compound. We also have a group of compounds called the arene. The ones we said they are called the aromatic compounds. So in aromatic compounds, the functional group is the benzene. This is the benzene. That is the one which represents the aromatic compounds. Then we have alkyl halides. Alkyl halides, the functional group of alkyl halides is this halide, the halogen. And you can see it is represented by X here, where X is attached to the alkyl group, and the X can represent the fluorine, the chlorine, the bromine, and iodine. All of these, we are saying they are halogens, and whenever they are in a branch form, if they are substituencies, then we get a name called the halides. Then we have alkanes. the alkanes or alcohols. We also call this one the alkanes or alcohols. They have a functional group of OH. So whenever you see OH somewhere, that is the functional group of alkanes. Then we have phenol. Phenol has a functional group of the benzene plus OH. So these are benzene with OH, alcohol benzenes. Those are the ones we call the phenol. Then I'm going to give us the common ones. Thiol is not very common to us, but we shall look at it in our next session. Then we have ether. Ether, I believe most of us have heard about ether. For them, the difference between ether and any other organic compound, for ether has one oxygen atom which is attached to other alkyl groups. You can see here we have this alkyl group, we have also this alkyl group, and they are joined together by an oxygen atom. So that is a functional group. Whenever you see organic compounds with such, then we say those are ethers. This one we shall look at it in our next session, and also this we shall look at it in our next session, plus epoxides and also the amines. We shall look at them in our next session. But of course, as I said, keep on pausing and you note down all these functional groups. Note them down. What I know is that in our next session we shall look at those ones that I'm underlining. So we have nitrile. These ones we shall look at them also. Then another thing we're going to look at is a ketone. Ketone, it has a functional group of C to O, but with a double bond. Then it is attached to two alkyl groups on both sides. When we look at the difference between a ketone and an aldehyde, which we're also looking at, for an aldehyde is at terminal, while the ketone, this group is inside, in between the different alkyl groups. So for ketone, it has that functional group you see here in between, while the aldehyde, for it is on the terminal, it is on the side. So this represents an aldehyde. Then another one, we have a carboxylic acid. Carboxylic acid has this functional group, the one we normally call the carbonyl group, which you can also write as COOH. It is also written like that. Those are the ones we are going to be looking at in this session. For ester and amide, we shall look at them in our next session. So don't forget to keep on look when we publish our second session in organic chemistry. We shall be looking at those particular compounds that we have not looked at in this particular session. Let's also look at these two tables. We talked about prefixes and we also talked about the alkyl groups. Now, how are these prefixes helping us? These prefixes help us. If you know the number of carbon atom, you can get to know the prefix and therefore help you to know the name of a given compound. You recall, let me give an example of the organic compounds we have talked about. For example, the alkanes. We also have the alkenes. We also have, let me give the alkanes. The alkanes. We have alkanes, alkenes, and alkenes. Now, if you look at this table, it is having the prefix. Prefix, if we say that is the one which comes first. And then here we have the meanings. So we are saying that meth, it stands for only one carbon atom. If it is one carbon atom, it starts with the prefix meth. 2 carbon atoms, it starts with prefix eth. If it is 3 carbon atoms, prop. 4 carbon atoms, but. 5, pent. 6 carbon atoms, hex. and then 7 carbon atoms hept, and 8 carbon atoms oct, 9 carbon atoms we have non, and then 10 carbon atoms is the one we call the deck. Now, how do these ones help us? For example, let's talk about an alkane. An alkane with how many carbon atoms can we consider? With 5. Can we consider 5 for now? Then for you can try for other carbon atoms. An alkane with 5 carbon atoms. One thing we know about alkanes, they have a suffix n. They have suffix n. And we have seen that the prefix we are looking at, if there is 5 carbon atoms, is pent. So therefore, the 5 carbon atom alkane, we can call it the that is a pent, that is our prefix. Then we add the suffix for alkanes, which is n, and the word is pentane. When you go to alkenes on the same 5 carbon atom, for alkenes, the difference between alkane and alkene is that for alkane it has suffix n, and alkenes have suffix in, and therefore for this one now becomes pent in. I believe that one now becomes clear. Then for alcohols, for them, what they have as their suffix is all. So if we are looking at 5 carbon atoms, it will become pentano. So it becomes pentano. So, but now you see what is common? Prefix pent. If it is 3 carbon atoms, now it becomes prop, it becomes propane, it becomes propene, it becomes propano. If there are 9, then we come and say nonen. If it is alkene, it becomes nonin. And then for alkanos, it becomes nonano. That one is nice. Nonano. Nonano. Then here it becomes no nin. Then here it becomes no nen. I think so. The prefix remains non. It becomes non. Becomes non. Nonano. Nonin. And then nonen. So that is the importance of these prefixes. They help us to know the names and what we are having for any, if it is 2 carbon atoms, 3 carbon atoms, we get to know which prefix can we use. Then we have these alkyl groups. Now for alkyl groups, we said these are the substituencies. When you look at 1 carbon atom, alkane with 1 carbon atom is CH4, and its name is methane. Now, when 1 hydrogen is removed and that those electrons are used to form this bond, a branch, then it attains ill. Now it becomes an alkyl group. And if it is having 1 carbon atom, we call it a methyl group. When there are 2 carbon atoms, you can see here we have 1, 2 carbon atoms, it becomes ethyl. At least we have seen it from here. When there are 2 carbon atoms, they have a prefix of eth, and then because it's an alkyl group, it becomes ethyl. Then for 3 carbon atoms, propyl. For now, here, these are still 3 carbon atoms, but it is having a branch. So when it is a branch in a branch, and it is having 3 carbon atoms still, then we call it isopropyl. Then if there are 4 carbon atoms which are forming the branch, then we call that one the butyl. Then the butyl, 4 carbon atoms with a branch, like the way we have seen in here for 3 carbon atoms. So here it becomes isobutyl. Now there is when the branch is on this carbon atom, the first one, and there are still 1, 2, 3, 4. The difference is the position of these branches. So this one becomes sec, secondary butyl. Then here, where the branches are many, then we call it tertiary butyl. But you can write it in simplified form, and we say tert butyl. I believe we are used to these forms, like when they write it like this, meaning that here we have a methyl group, here we have a carbon atom. So every corner represents a carbon atom. I believe we know that. We have put it here so that whenever we see such, we don't get perturbed in any way. Now, having known all these, I want us to go direct to some examples, and we use our guidelines and then we name. Please, as I said, you can keep on pausing. Like now, you first pause and try naming this using the rules that we have discussed. If it has a branch, then you also still use the same, and then after that you can be able to mark yourself. Let's look at this. How do we name this compound? Now here they have written the structural formula, but also we can write this one as CH3, which is attached to CH2. This is the first carbon, this is the second. Now the third is also attached to CH2. Then the fourth is also CH2. Then we have the fifth, it is also CH2. Then the sixth is CH3. So this is the same compound. This is the compound which is the same as this. So we said the first guideline is to identify the longest chain. Now this is only straight chain, so the longest chain is that becomes our longest chain because this is straight. Now something which is straight chain and having no branch, the longest chain remains the straight chain. Then we count the number of carbon atoms. 1, 2, 3, 4, 5, 6. These are 6 carbon atoms. Now, if there are 6 carbon atoms, we also need to identify the functional what? The functional group. Which functional group do we see here? We can see that all the carbon atoms are joined by a carbon-to-carbon single bond. Carbon to single bond, meaning this is an alkane. Now, an alkane with 6 carbon atoms, how do you call that? You call the prefixes. Now, when you have the prefix for 6 carbon atoms, we say the prefix is hex. Now, because it is an alkane, then it has N, and then it becomes hexane. So that is the name. For you, wherever you are, you can try this one. Let me put for you this CH3, CH2, CH2, and CH3. Try this number and you put it in the comment section. You tell me the name. I want to know what is the name of this. I'm calling it number 1. So you say number 1, its name is this. I get to know whether you have gotten the concept that we have discussed here. Okay, I'll be giving you some trial numbers to try, and all your responses, make sure you put them in the comment section. Let's look at the second item. This was the first one. Then we have second one. In the second one, we are going to still use the same rules. You recall we have 5 guidelines. And the first guideline says we identify the longest chain. So the longest chain, if you move like this, we have this chain, the straight. We have the straight chain, but also there is this movement. What if you pass here? What if you pass here like this? How many? Let's start with this one. We have 1, 2, 3, 4. 4 carbon atoms. Okay. Let's look at this straight one. 1, 2, 3, 4, 5. 5 carbon atoms. Meaning this one is our straight chain. And don't forget, the longest chain is the one which gives us the parent name. And if you look at this compound, it is also having single carbon to carbon bond, meaning it is also an alkane. But an alkane which is blanched, it is having a what? A blanch. But we have already seen that it has, the longest chain has 5 carbon atoms. Now the second thing is to number. That was our number 3. After identifying the function, then we can go to number 4 by numbering. So we number. Here this is 1, this is 2, carbon 3, carbon 4, carbon 5. This is from this side. We can also number from this side, and we see this one becomes our carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and here we have carbon 5. So we say that substituencies should always take the smallest or the lowest number. Now when you move from this side, we see that the substituent of ours, which is a methyl group, alkali group which is methyl, is taking the 3rd position. While when we move from this side, it is still taking the 3rd position. We say that whenever we have such a substituent, we call that one a methyl. So this one becomes the position, its position is 3. So it means that it becomes 3 methyl. Methyl what? You recall the longest chain. 1, 2, 3, 4, 5. Alkane with 5 carbon atoms, you recall the prefix is pent. And because it is an alkane, it becomes pentane. There is N here. Pentane. Pent. The prefix was pent. So when you add, it becomes pentane. So that is our correct answer there. And this was our correct answer, the hexane. I'll be giving you a practice item on this blanched alkanes. Let's first look at our next. Hope this one is very clear. Let's look at these other 2. Okay, now we have another item here, and we need to identify the name. You don't forget we are still using the IUPAC system. In IUPAC, we have guidelines that we follow. The first guideline is to identify the longest chain. Which one is the longest chain? Let's first see. Let's start with the straight one. When you come in straight line to see our chain, when you come like this, this can be the first one. What if we also move like this, and we move from up there, we move like this, also we have this. So you can see there are some 2 chains. We want to identify which one is the longest chain. So in this first one, we see 1, 2, 3, 4, 5, 6. Then the second, we have 1, 2, 3, 4, 5, 6. Oh, they are equal. So which means our parent name, do we see that the functional group still remains carbon to carbon single bond? So if it is still the same, then we don't need to waste much time. We consider N. So for me, I'll consider the straight chain. For you, I don't know which one you're considering, but for me, I've considered the straight chain, which is having 1, 2, 3, 4, 5, and 6. Or we said we can start from up here. 1, 2, 3, 4, 5, 6. So in our procedures or guidelines, we said after numbering, we give these substituencies the lowest number. So we can see when you move from this side, when you are moving from the other side here, from this direction, we see the first group of substituencies, which are the methyl groups. They are on carbon 2. Then this substituent here, which is an ethyl group. So in simple terms, the alkyl groups we are having the methyl, and we also have the ethyl. Those are the branches that we have. So the methyl groups, we have them on carbon 2. The ethyl group is on carbon 4. I believe you see that. That is for the first, when you're using this direction. Now, when you use this direction, the first one is ethyl, which is on carbon 3, and the other methyl groups, these ones here, we can see that they are on carbon 5. So because they are 2, so we say 5. Are you seeing that? So now when you look at this, which direction becomes better? I'm going to give you a simple technique that you can always use. For example, now, if you sum up these, here it is 5 plus 5, 10 plus 3, it becomes 13. Here it is 2 plus 2, which is 4, plus 4, it becomes 8. Now, 8 and 13, which one is small? 8 becomes smaller. So we consider that one, which means we consider this slot. But now, don't forget, we have ethyl and methyl. Ethyl and methyl, which one comes first in alphabetical order? So we also consider the alphabetical order. So ethyl, E comes first compared to M. So we are going to first write E. So E is ethyl and it is on carbon 4. So you say 4 ethyl. Okay. Then methyl is on carbon 2. Then you say 2. But on carbon 2, there are 2 what? Methyl groups. So you say 2. Because there are 2 which are the same, we now say dimethyl. What is the parent name? The parent name, we get it from the longest chain, which you say it is 1, 2, 3, 4, 5, 6. 6 carbon atoms, and it is an alkane. The prefix is hex, because it is an alkane, becomes hexane. So our substance is known as 4-ethyl 2,2-dimethyl hexane. And you get your answer. Very, very right. You try out this you try out this, and then you let me know your answer in the comment section. This is number 2. You recall the other one was number 1, and now this is number 2. I want to give you the one with blanched. We have CH3, CH. We have a blanch CH2, CH3. We have CH2, CH3. That is the compound I want you to try, and then you let me know which answer you have gotten in the comment section. I'm waiting for you to see whether we are moving at the same pace. That is number 3. I want to add you also that's number 2. Let me add you number 3, where it has a number of branches, and you try out. Here we have CH3, and then we have CH2, CH3, and then it continues CH2, CH2, CH3. And also this one, I need to see the answer. Yeah, at least there, when you answer those 3 items, I will say that we are together. So make sure you put them in the comment section, and then I will see what you are getting. Now, here we come to our next example, which we want to work out together. Now, here they have used bonds. They are not showing us the carbon atoms, but we said on each and every corner there is a carbon atom. There is a carbon atom, carbon atom, carbon atom. What is the longest chain? They have already shown it once. 7 carbon atoms. And we say that 7 carbon atoms, they have a prefix of hept. And because we see even this one, by the way, it is an alkane. So which means the long parent name is heptane. And now we are looking for branches. Which side can we start with? Already they have numbered for us from this end. This end they have already numbered for us. Now can we count from this end? This will become our first carbon atom. This becomes the second carbon atom. This one becomes the third. This one becomes the fourth. This one becomes the fifth. This one becomes the sixth. And this one becomes the 7th. We are going to name. We are going to give the numbers in all times, and then we consider which one is correct. Now, using this direction, we see the methyl groups. One is on carbon 2, another on carbon 5, methyl. Then the ethyl group is on carbon 4. We say that we need to consider the alphabetical order. So it becomes 4 ethyl, 4 ethyl. Then the first methyl is on 2, and then the other one is on 5. Because they are 2 which are the same, we say dimethyl. The parent name is heptane. Now, in this case, I'm using this slot. Now, can I use the second lot? And we see when I use this slot, the methyl group, the first one is on carbon 3, the other one is on carbon 6. Then the ethyl is on carbon 4. So the ethyl remains on carbon 4, so it becomes 4 ethyl. Okay, 4 ethyl. This one is on carbon 3, 6 dimethyl. Still the parent name remains heptane. Now, for you to prove whether you have passed or not, we can use our knowledge of summing up. Are you seeing here? We sum up. When you sum up these ones, here we have 4 plus 2 plus 5. We get that is 6 plus 5, that is 11. Then here we have 4 plus 3 plus 6 plus 6. What do you get? Here we have 4 plus 3, 7 plus 6. There you get 13. Are you seeing 13 and 11? Which one is smaller? 11. So this one becomes our correct answer. And this one is not correct. So when you are numbering, you have to number, and we consider the one which gives us the smallest sum. Hope we are together, and make sure you try out these 2 numbers. These are trial numbers. There's another one I gave you to try. So far there are 3 numbers. Let's go to this page. In here we have one example of still an alkane, but in another form, in cyclic form. And we are saying that we can draw it in this format, or we can show what each corner represents. I had already said that these corners you see, they represent a carbon atom. There is a carbon atom. There is a carbon atom. Carbon atom. Carbon atom. as reflected here. At least we have been able to reflect it here. So we can write it like this, or we write it like that. So if there are 6 carbon atoms, we say that the parent name, because it is single bond, it is an alkane, and because there are 6 carbon atoms, then it gets the hex, which is the prefix. And now because it is an alkane, it becomes the N, hexane. But the difference between this and the other one we had at first, this one is in circular, so it attains a name called cyclohexane. So the name becomes cyclohexane. Hope that one is clear. Then there's this one which I wanted you to try. Could you please try out this from what we have discussed? Can you try this and you give me the answer that you get? You try it out. Identify the longest chain and then you'll be able to give me the answer. I'll be waiting for your response. This is number 4, trial. Let me hope I've given you a number of trial items which I believe you're going to enjoy. So that is number 4. You try those that number plus the other 3 items and we see. Now, we also talked about an aldehyde, we talked about a ketone, we also talked about carboxylic acid. And we're going to look at some examples we're going to name. So the aldehyde, we said it has a functional group of this is a terminal, carbon to oxygen, and that is the functional group for aldehyde. It is always on the terminal, while on the ketone, for it is in between, is in the center of the alkyl group this side and alkyl group on the other side. Then for carboxylic acid, they have a carbonyl group of COOH, and then the other one is an alkyl group. So we are going to see some examples which you are going to name, so long as you have understood that they have different functional groups, and those functional groups are the ones which determine how they behave. Determines how they behave. Here I have 4 items which you are going to try out together, and then you can go outside there and search for more items and try them by yourself. Then if you get any challenging item on regard to what you have discussed, then you can bring it and we discuss. Now let's look at this item. This one, this compound, we see having a functional group OH. We said that OH, those ones with OH, those are called alcohols, which means this is an alcohol. But our guidelines of naming, we say that we look for the longest chain. I'm here looking for the longest chain. I'm here looking for the longest chain. I'm here looking for the longest chain. So you can see that here we have our longest chain. Hope that is the longest chain. Now, after that, we number. Now, when we are numbering and we have a functional group, this is our functional group. This time round, you don't have an opportunity to go and start from behind here. No, we have to start where it is closer to the functional group. So the functional group is here, OH, and therefore we need to start from here counting. This becomes number 1. This is number 2, carbon 3. This is carbon 4, and this is carbon 5, which means this is a compound having 5 carbon atoms, but is an alcohol, so which means becomes pentanol. That is a parent name. But now, even the functional group has its position. It is on position number 2. Still on position number 2, there is another branch of an alkyl group, which is methyl. So what do? So we can first cater for the branch which is on carbon 2, and we say it is 2-methyl. Okay, now we said the longest chain is 5 carbon atoms, and therefore it becomes the prefix, which is pent. Now because these ones are alcohols will add the an, so it becomes 2-methyl. Oh, no. We have also the position of the alkali of the functional group. Even the functional group is on carbon 2, so which means it becomes 2-methyl pentan. Now we put the position of this functional group on, so it is pentan 2 on. Are you seeing that? And you get your score. Okay, let's look at this other item here. Now here we also look for the longest chain. I can see when I move in a straight line, I can get the longest chain. Okay, this is the longest chain. And which one is the functional group? This is an alkali halide. So the functional group is here. It has been labeled with a green color. So which means we need to count coming from down from this side. So this is 1, this is 2, this is 3, this is 4, this is 5. So the parent name becomes pentane, because the whole thing is having single bond, but it has a substituent of a halide and another substituent of alkyl group, which is methyl. So the halide is on carbon 2, the methyl group is on carbon 3. This halide is kulolo. This is kulolo. And then this one is methyl. Kulolo and methyl, which comes first? C comes faster than M. So which means we say 2 kulolo, 3 methyl. How many carbon atoms? 5. So methyl pentane, and you get your score. So you can see how nice it is when you are naming our compounds. Let's also look at this. Here they have used the other format, and I believe now we know that here we have a carbon atom, here we have a carbon atom, here we have a carbon atom, and here we have a carbon atom. Which group does this one belong to? Identify the functional group. Do we see that this is an aldehyde? From what we have seen already, this one becomes an aldehyde. Now, if it is an aldehyde, and this is our function group, which means when we are numbering to look for the longest chain, we will start from where this is the function group, carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon 5. Now we see that on carbon 2 there is a substituent which is methyl. So this becomes 2-methyl. Because there are 5 carbon atoms, 5 it is pent. But because it is under aldehyde, and therefore we say pentanal, and you get your score. Pentanal. Okay. Finally, let's look at this last part. This last part I wanted to reorganize it, and then we'll see whether we can name it very well or very fast. Now, when you look, I want to interchange. This one comes the other side, this one goes this side. But we can still name it. Because when you see this, this is the functional group here is a carboxylic what? For carboxylic acid, the carbonyl group. and therefore we start numbering from where the functional group is. So this one becomes 1, this is 2, this is carbon 3, this is carbon 4, this is carbon 5, and then here we have carbon 6. Most of people were leaving out this, and yet this one shows that there is a methyl group here, and therefore if you are looking for the longest chain, you can see it will be part, and chlorine will be a branch. So when we are doing that, we can now see that chlorine is on carbon 5, and finally we can say it is a 5-chloro. How many carbon atoms? 6. So hexanoic acid. 5-chlorohexanoic acid. So we can look for more carboxylic acids, and we try other examples, and when you get the solution, you also submit. If anything disturbs you, just upload there on the comment section, and then we shall be able to respond. Otherwise, I want to thank you for attending and being part of this discussion. Those items that I have given you in as we have been discussing, there are 4 items I have given you to discuss. Do them, and you put your responses just in the comment section. Otherwise, just keep on enjoying the beauty of chemistry. If you have not yet subscribed, just click on that subscription button, like and share with your friends. One thing you need to know is that sharing is a key. We have shared with you this content. Also make sure you share with your friend so they can also benefit from whatever we are discussing. Otherwise, God bless.